This video will cover how to interpret the logistic regression, specifically focusing on the output from SPSS. So first, to just give you a little bit of background, this was on that data set looking at smokers versus non-smokers and their level of stress and amount of free time. So really what we were looking at is looking to see if stress and free time are predictors of whether one smokes or not. Or, to put it in terms really closely with logistic regression, how much your odds increase of smoking depending on your stress and free time. So how much your stress and free time impact the odds or the likelihood of you smoking. So to just quickly review, a null hypothesis for logistic regression might sound something like, the null hypothesis is that there is no difference between the model with only a constant and the model with independent variables. Or said another way, that there's really no predictive value of stress level and free time with regard to whether one smokes or doesn't smoke. So let's go ahead and look at some of the output you get. The first important table you get, now remember there are blocks, block 0 and block 1, and so I'm going to kind of skip over some of those tables and focus only on the important ones. The first one that you get is this ominous test of the model coefficients. You'll notice right away that this is a chi-square test. This is going to be similar to the ANOVA table that we looked at in linear and multiple regression. This is going to be looking at whether it's significant or not. So ultimately, whether we're rejecting the null or not. So right away, what we'll go ahead and do is look right at the model, and we'll notice right away that it's significant. So what that's saying is that we're going to reject our null. We get to do a happy dance, jump up and down, celebrate a little bit. And then really what that's saying is that there is a relationship between the independent variables and the dependent variables. Or to put it back with regards to our null hypothesis, that constant, the model with only the constants, is different from the model with the independent variables. Or, said another way, to put it in frames of the example data we used, that stress and free time do have some kind of relationship to the odds of one smoking or not. And remember, we don't know which one it is or if it's both. We just know that there's something going on there. So it's similar to an ANOVA where it says, hey, there is a significant difference, but you don't know what groups. And so you have to do further kind of follow-up. Here, again, this is just saying, hey, it's significant, but it's not telling you exactly what is significant. So then, if we look at that line, you'll see the model chi-square number, that 26.971 degrees of freedom and significance. So you might write something like, there's a difference between the model with the constant and the model with the independent variables. Chi-square, that's that kind of cursive looking x squared, and then I put degrees of freedom in there, and then put what the chi-square value equals, at 26.971. Of course, p less than 0.05, just letting readers know it's significant. The next table that's going to become important to look at is the model summary table. This is where you're going to see your log likelihood, the value that we've read about over and over again in Field that he talks a lot about. And this is the value that you're going to use to calculate R squared. Then you also see next to that the Cox R squared and then the other R squared. And I'm going to talk a little bit about those in a minute. Let me cover the -2 log likelihood first. So that value in this instance is 14.618. And that value becomes important because that's the value you're going to use to calculate the R square value. So I just write that number down or save that table in a Microsoft Word file or something, because that number you'll need to actually calculate an R value. Now, I'm going to show you I'm going to kind of refresh your memory on how to calculate that R square value, but I'm also going to tell you those two other R square values you see, the last one maybe I would avoid, but the Cox and Snell R square value, I think is, from my experience, now remember I haven't tested every single data set in the whole US, but from my experience of looking at data sets, those tend to be pretty close, the -2 log likelihood and the Cox and Snell R square. So sometimes you could just use that Cox and R squared value if you wanted just a quick understanding of how much the amount of variance accounted for. But I'm going to show you just how to calculate that. As I said below, you're actually probably okay citing one of those. I would go with the Cox over the other one, Again, that's just my personal experience because they are typically fairly close. The last one seems a little bit more inflated from what I've noticed in the data that I've worked with. Again, this is going to differ from data set to data set, and it's also going to differ from the number of variables you throw in, and missing data, and variables are skewed, and assumptions, and all that kind of stuff. So it's something to be mindful of, but if you're just running your data quickly and you just want to look at R squared and you don't have a calculator on you or you can't remember the formula, you could probably look at the Cox one and get a rough idea and then calculate it later. So we're going to write down that 14.618 value. That value is going to come back in a moment. But let's go on to the next table, because you actually need this table, the variables in the equation, one of the last tables to appear in SPSS in the output. This table is actually going to help you calculate the R square value. But before we calculate the R square value, we need to see, hey, which one of these is significant? We have stress level thrown in as a predictor and free time. So let's look at this table. You probably notice right away that stress level is the only one that's significant. So that significance value that's circled there in red is less than 0.05. So we get to jump up and down, do a little happy dance, and then now comes the time to interpret it. So let's focus on stress level right now. So looking at stress level, we have the walled value, the degrees of freedom, and significance. Actually, the walled and degrees of freedom are the two values, in addition to that value I told you to write down, the -2 log likelihood, to calculate R squared. Now, if you look in the field textbook on page 786, if you have the 4th edition, if you have an older edition from another class, like maybe say the 3rd edition, you'd have to look up the exact page number. I apologize. I just had the 4th edition laying around, and so I looked it up there. But on page 786, he walks you through the formula. What that formula is it's actually, I believe this is coming from memory, so don't quote me on this. Look it up just in case. But it's the walled value minus 2 times the degrees of freedom, I think, divided by your -2 log likelihood, and then the square root. So what I've done is I've taken 7.791 minus 2, because 2 times our degrees of freedom of 1 is 2. So 7.791 minus 2, and then I've divided that by our -2 log likelihood, that 14.618, and then I've taken the square root of that. And I got roughly 0.6294087, okay? Now remember, if your value's off by a little bit, don't panic. It's probably just rounding. If we all round differently, and so, but I get roughly 63% of the variance in smoking, and whether one smokes or not is accounted for by stress level. So now we have our proportion of variance based on stress level. Now let's talk about what is the odds? Where's the meat? Where's the butter? Where's all that exciting stuff? So let's look at that last column, that EXPB, sometimes referred to as the odds ratio, which you've read a lot about. And so the odds ratio value, or that exponent B, is 2.200 in this case, which implies that for every 1 unit increase in stress, the odds of being a smoker increase by 2.2%. So if that value, I'm just pausing for a minute to let you catch that, if that value is less than 1, it's a different interpretation. So remember, and I think Field does a pretty good job of describing this in one of those, I don't know if it's the CRAM, I forget all these names, if it's like Summary Sam or CRAM, whoever, I can't remember. I apologize, I can't remember the character's name, but I think they do a pretty good job of explaining it. If it's higher, if the value is higher, then it's as one increases the other. But if it's lower, then as one increases, the other decreases. Your odds decrease. So keep that in mind as you're interpreting. For this one, it is saying that as your stress increases, or people with more stress are more likely to be smokers. That's what it's saying kind of in a nutshell. So, of course, that's stress. We haven't talked about free time, so let's look at that next. You'll notice that we look at free time, not significant. So you get to jump up and down a little bit because you don't have to write a sentence. So that's sometimes kind of fun. But it's sometimes, you know, is a little disappointing if you were hoping that free time played a role in whether one smokes or not. So it's not important, it's not significant. So you don't have to focus on interpreting it. Typically, things that aren't significant we don't talk about in journals or dissertations, theses, those kinds of things. So that sig value 0.097 is above 0.05. So we're just going to go ahead and ignore it. So let's take everything we just talked about and put it into a result, kind of a results write-up. So in a few sentences, this is something I would say. I would say something like, there's a difference between the model with the constant and the model with the independent variables. And then cite that chi-square thing again. So that's really saying, hey, it was significant, so I get to proceed. And then I would say something like, when examining the two predictors, only stress level was significant. That's just kind of to let readers know, hey, I did look at time, nothing there. So I just want you to know, I knew I had two predictors. I didn't forget one. I did look at both, but only one was significant. And then a quick interpretation. Again, similar to what we just saw on the last slide, but for every 1 unit increase in stress, the odds that respondents smoke increased by 2.2%. So as your stress goes up, the likelihood or the odds of you smoking increase. And that's an example write-up. I hope that helps clarify some of the outputs in SPSS and a little bit on how you write that up. If you have any questions, don't hesitate to contact me.